Okay, everybody, we are here in chapter 7, and we're going to talk about something that you're familiar with. We're going to talk about percents, decimals, and fractions. Today, we're going to look at section 7.1, and we're just going to talk about fractions and percents. So let's get started. So our vocabulary today points to some information that I think you guys probably remember. We know that percent is a ratio that compares a number to 100. And the word percent we can think of as per 100. And we know cent, that prefix is a prefix for things that deal with 100, like century or centipede or, cents, like in money. So that should be familiar to you guys. Let's take a look at a couple examples. So example 1, we have percents as a fraction, and the first thing that we're going to do is change each of these percents, so 60% and 12.5%, into fractions. And it says write each percent as a fraction in simplest form. That last piece is really important. So when we do things in simplest form, let me make this a little bit larger. When we do things in simplest form, what we get to do is not just put this percent over 100, which is legit in terms of turning it into a fraction, but we also must reduce. So I can look at this and easily we can see 10 goes into both of them. So the 0 goes there, and then we've got 6 over 10, and we can obviously see that 2 goes into the numerator and denominator. So 60% is the same as talking about 3/5. So if I'm talking about 60%, I'm talking about 3/5 of something. Let's do the same thing over here, but it doesn't look as easy. This fraction is probably bothering somebody right now, but do not be afraid. We've got a couple ways of doing it. We could do 12.5, which is the same as 12.5 over 100. You know that we don't mix this decimal fraction business, so I would multiply the top and bottom by 10 in order to eradicate the decimal situation in the numerator but maintain equality. So I get 125 over 1,000, and then I get the fun task of reducing. So I look at this and I'm like, 25 can go into both of these, I'm sure. 25 goes into the numerator, so I'm dividing top and bottom by the same thing to reduce. 25 goes into the numerator 5 times. So I have a 5 up here. How many times does 25 go into the denominator? Hopefully you guys can do that in your head, or at least on paper without a calculator, and you recognize that the answer is 40. I think I can stop, but then I look, 5 and 40 have a common factor, and it's 5. 5 goes into itself 1 time, 5 goes into 40 8 times. So my answer to this is 1/8. Your text did this example problem in a slightly different way, so I want to present that to you as well. So they started off by doing exactly the same thing. The authors put 12.5 over 100. 12.5 over 100 is the same thing that we started off with. However, when they saw, or when they recognized that they had this fraction here, they turned it into a mixed number. So we had, or this mixed number into an improper fraction, which would be 25 over 2 over 100. So now this is taking a fraction and dividing it. So I have a fraction, I'm going to divide it by a number. How do I divide fractions? So back in chapter 3, we talked about this. 25 over 2 times the reciprocal of the denominator, that's 1 over 100. And we can cross cancel beautifully. We see that 25 goes into itself 1 time, and 25 goes into 100 4 times, and you see we still get the 1/8 when we multiply 1 times 1 and 2 times 4. So there are many ways to attack these problems, but the ultimate piece is that you need to put the percent over 100 and reduce it as best you can. Let's take a look at example 2. Example 2, let's see if I can get there. Example 2 is going to deal with specific cases that confuse all of us. The fact is, we're so used to percents being out of 100, sometimes when it's out of something larger than 100, like 175, that causes confusion. Or when the percent is less than 1, it causes confusion because it looks like a decimal. It's like, what are we talking about here? So what we're going to do is we're going to show how to change both of these. So let's start off with part A. Part A, we're going to change this into a decimal by doing into a percent, by doing exactly what we said we would do. We take the percent, we put it over 100. Now, the decimal fraction business doesn't work, so I'm going to multiply top and bottom by 10, and I'll even write that out for you. I didn't do it in the last example, but hopefully you guys were able to follow along. When I multiply 0.8 times this 10, I get 8 over 100 times 10 gives me 1,000. And so now I get to simplify this thing. So I can divide both top and bottom by the same number and see where I come out. I think we dealt with 1,000 last time. So we should recognize that if I divide the numerator by 8, I can, in this case, I can divide the numerator and the denominator by 8. And so if we just take a brief moment to think about that, we can recognize that 8 goes into itself one time. 8 goes into 1,125 times. So 0.8% is like 1 out of 125. All right. And over here, we see that we have a percentage that is greater than 100. So we should expect that our fractions numerator is going to be greater than the denominator, which it is, 175 over 100. And of course, I can reduce this. 25 goes into the denominator 4 times, and 25 goes into the numerator 7 times. So when I could leave this like this because I'm kind of a fan of improper fractions, to be honest with you. But if you were to break it down even further and write it as a mixed number, you would get 1 and, I think, what's that, 1 3/4. So either of these are acceptable, and that's pretty fine for me. Let's take a look at another example. So here in example 3, we are taking our fractions and writing them as percents. So this is really right up your wheelhouse, especially after finishing the last chapter, chapter 6, where we were doing some interesting things in terms of scale drawings and trying to figure out, trying to solve proportions particularly. So in problems like this, I like to actually solve them started as a proportion. We know that we want to create a fraction with a denominator of 100, and we know that if we can find an equivalent fraction with a denominator of 100, then we know that the answer we'll get in this red box here is going to be the percentage, because the percent is out of 100. And many of you can probably look at this and say, oh, well, 1/4, that's like 25 out of 100, so the answer is 25%. If you did that, you are correct, right? One way you can do it when it is not so obvious is you can set up this relationship, this proportion, and you could literally put an X here, and you can do what we did in the last chapter to solve these, which was to cross multiply and do your thing. So I've got the answer. I know you got it. That's cool. But we're going to cross multiply just to practice that skill. So 4 times X is going to give me 4X, and 1 times 100 will give me 100. And then I'm going to divide both sides by 4, and I see that the X indeed is 25. So if that helps you, that might be a way to handle these problems. And we'll probably do that here. So let's see. I've got 6 over 5, and I know that I need to figure out what this is, what goes in this box here is going to be my answer, because that will be the percent out of 100. And so I'm going to put an X here for the time being so I can solve that. So when I cross multiply, I end up with 5X is equal to 600. So the next thing for me to do is to divide both sides by 5. And when I do so, I get that X is equal to, what's that now? What's that, 120? I think that's right. So X is equal to 120. So this is being referred to as 120. I don't know why I wanted to put 5. I'm sorry, people. I'm a confused woman. Let's go back. This is 120%. So when I have 6 out of 5, that's 120%. All right, let's look at another example. Okay, so example 4, fractions as percents. On her science quiz, Niall, not Niz, but Niall got 14 questions correct out of 16. Find Niall's grade as a percent. And you guys, this is totally useful for us, right? When you have a test that's not out of 100, which most assessments aren't, you can simply figure out, you start off with the amount that you got correct out of the total amount, and that's going to be equal to X out of 100%. And then we're going to cross multiply and solve this. A little thought that I want you guys to keep in mind, and your textbook doesn't come up with it immediately, but it's something that we're going to talk about, and I think it's pretty useful to talk about, even though I think your textbook probably waits till section like 4 or 5 in this chapter to discuss it. There's a concept, and I'm sure we talked about it in 6th grade. Part over whole is equal to percent over 100. I don't know why I chose that slanty thing there. Let me do that again. Let me do it straight away. So part over whole is equal to the percentage over 100. This is like totally, keep it in the back of your mind, keep it in your handbag, wherever. It is so useful and it's so beautiful to use. It's just like my favorite thing in the world, one of my favorite things in the world to use in math, because it's just so completely useful and it makes sense and it kind of reiterates what a percentage is. So the whole, and I'm thinking about this in reference to this problem with Nile, the whole thing quiz had 16 points or 16 problems. She got the part 14. I want to know what percent that is out of 100. And again, we're going to cross multiply. So hold on to that. That's a good thing. So we get 16x is equal to 1400. Again, multiplying these two and then multiplying these two. So when I divide both sides by 16, we'll get, what will we get? I think 87.5, something like that. I'd probably use a calculator, not a thing, to figure it out. You could also rock some long division. That's not a problem. So if this were the situation, this is the grade that now we get, possibly rounded to an 88. So she'd get a B+ on this particular quiz. All right, let's take a look at, I think we have one more example. I might be making that up. Yes, we do. Rounding percents. All right, Mason discovered that 4 out of every 11 8th graders at his school play games online. Yeah, I think that's right. Okay, find the percent of 8th graders that play games online. Round to the nearest 100. Again, in my mind, I am totally thinking about part over whole is equal to the percent over 100. So useful. So the part that we're talking about is 4, and the whole number of students that we're talking about in this particular example is 11. So 4 out of every 11 students. So I start off with 4 over 11 is equal to, I'm looking for the percent, so I'm going to rock an X there, over 100. Cross multiply and do my thing. All right, so I'm going to have to divide both sides by 11, right? And when I do that, I get that X is equal to 36.36. I think this goes on forever and ever, if my calculating is correct. And so we were asked to round to the nearest 100th. Do we remember what term the 100th is? It's the second term, right? It's right here. So what would we round to? It would stay just there. So we see that 36.36% of 8th graders at Mason School plays video games online. All right, guys. So that's our lesson for today. I think you guys can handle all of the problems in the packet that are associated with this section. Make sure you let me know whatever question you have about the notes or about the problems, and I cannot wait to see you. Have an excellent day.